Hello 7th grade, this is Miss White, and today we're doing lesson 12, properties of inequalities. So let's look at example 1 here. It says, preserves the inequality symbol. Well, what does it mean to preserve the inequality symbol? Well, this means that the inequality symbol stays the same. What about reverses the inequality symbol? What does that mean? Well, to reverse it, it means that the inequality symbol switches less than with greater than and less than or equal to with greater than or equal to. Let's look at station 1. In station 1, we are going to pretend that we are playing a game and that we're rolling dice. So we have 2 dice that we're rolling here. Here's our die 1 and our die 2. And because we're pretending that we're rolling these dice also have negative values. So go ahead and follow along with me to fill in these values that we pretend roll for the die. So we're going to have 2 and 4, negative 1 and 3, negative 3 and 6, and positive 1 and positive 7. To fill the inequalities, I know that 2 is less than 4. I know that negative 1 is less than 3. I know that negative 3 is less than 6. And I know that 1 is less than 7. So right now, all our inequalities should be less than. So now let's look at our new inequalities. Here, our new inequalities are going to be combined with our operation. So our operation here is add negative 3. So we're going to add negative 3 to both sides of our inequality. So I have 2 plus negative 3 is less than 4 plus negative 3. So now we're going to look at both sides of our inequality. I have 2 plus negative 3, which is going to give me negative 1. And then I have 4 plus negative 3, which is going to give me positive 1. Let's put our less than symbol between them. Now, let's look here. I have negative 1 is less than 1. When I added my negative 3, did my inequality symbol change? No, it did not, so it is preserved. All right, let's move on to the next one. So I have negative 1 is less than 3. Here on both sides of the inequality, I'm going to subtract 2. So now I have negative 1 minus 2 is less than 3 minus 2. So here I have negative 1 minus 2. Another way to represent that is negative 1 plus negative 2. So negative 1 minus 2 is going to give us negative 3. So negative 3 is less than 3 minus 2, which is 1. So I can say that this statement is accurate because negative 3 is less than 1. And from our operation, Did our inequality symbol change? No, it did not, so it is preserved. Let's move on to the next one. I have -3 is less than 6. Let's go ahead and add our operation to both sides. So I have -3 minus -1 is less than 6 minus -1. To find the value of both sides of these inequalities, we first need to remember that when we subtract a negative, it actually means that we are going to be adding that value. So now I have -3 plus 1 is less than 6 plus 1. So -3 plus 1 is going to get us -2, and 6 plus 1 is going to give us 7, so I have -2 is less than 7. Again, when we put in our operation, did our inequality symbol change? No, it did not, so it is preserved. In our last one for station 1, I have 1 is less than 7, and I'm going to add 1 to both sides of the inequality. So I have 1 plus 1 is less than 1 plus 7. 1 plus 1 is 2, and 1 plus 7 is 8. So I know 2 is less than 8. So here, did our inequality symbol change? No, it did not, so it stayed the same, so it is preserved. I'm sorry guys, my dogs are eating right now. All right, so let's look down here. It says, examine the results, make a statement about what you notice, and justify it with evidence. So what I notice up here in this chart is that when a symbol is added or subtracted from both numbers being compared, the symbol stays the same and the inequality is preserved. Let's go ahead and start with station 2. Again, we are pretending that we are rolling dice that have a positive and a negative value. So we're going to go ahead and fill our quantities into the blank spaces. So I'm going to have -6 is less than 1, -4 is less than 2, -3 is less than 3, and -1 is less than 5. Let's look at -6 less than 1. We're going to go ahead and multiply both sides of the inequality by -1. So now I'm going to have -1 times -6 is less than -1 times 1. So I have -1 times -6. A negative times a negative is going to give me a positive. So -1 times -6 is going to give me +6. Then I have -1 times 1. A negative times a positive equals a negative, so I'm going to get -1. Now, I know that 6 is greater than -1, so I'm going to use the greater than symbol. Now, after our operation, let's see if our inequality symbol changed. Well, they did. So now the inequality symbol is reversed. Great, let's move on to the next one. So now I'm going to multiply -1 by negative 4, and that is going to be less than negative 1 times 2. So negative 1 times negative 4 is a negative times a negative, and so that's going to give us a positive 4. And then negative 1 times 2 is going to give us negative 2 because a negative times a positive is a negative. Now I know that 4 is greater than negative 2. Now let's look to see if our inequality symbols changed. And they did, so it was reversed. All right, now I'm going to have negative 1 times negative 3 is less than negative 1 times 3. So negative 1 times negative 3, a negative times a negative gives me a positive, so I have positive 3. And then I have negative 1 times 3, which is going to give me negative 3. And I know that 3 is greater than negative 3. So when I look at my inequality symbols, I know that they have changed, so they are reversed. And our last one, I have negative 1 times negative 1 is less than negative 1 times 5. I have negative 1 times negative 1, and negative times a negative equals a positive, so now I have positive 1. And negative 1 times 5, which is a negative times a positive, and that is negative 5. So I know 1 is greater than negative 5. I look at my symbols. Did they change? Absolutely. So the inequality symbols were reversed. Examine the results. Make a statement about what you notice and justify it with evidence. So when both numbers are multiplied by negative 1, the symbol changes and the inequality symbol is reversed. All right, so for station 3, we are only going to do the top 2 examples. So I'm going to have negative 1 is greater than negative 5. I'm going to have 2 is greater than negative 1. Now looking at negative 1 is greater than negative 5, I'm going to multiply both sides by 2. So I have negative 1 times 2 is greater than negative 5 times 2. So now I have negative 1 times 2, which is going to give me negative 2, and negative 5 times 2, which is going to give me negative 10. Now I know negative 2 is greater than negative 10, so did my inequality change? No, it did not, so it is preserved. All right, let's look at 2 is greater than negative 1. I'm going to divide both sides by 2. So now I have 2 divided by 2 is greater than negative 1 divided by 2. So 2 divided by 2 is 1. And then we have 1, and negative 1 over 2 is negative 1/2. So I know that 1 is greater than negative 1/2. So did our symbol change here? No, it did not, so it is preserved. So now let's examine the results. Make a statement about what you notice and justify it with evidence. Well, when both numbers are being compared and multiplied or divided by a positive number, the symbol stays the same and the inequality is preserved. All right, and here's our last station. Again, we're gonna fill in the pretend dice that we roll. So I'm gonna have 2 is greater than -1 and 1 is greater than -5. So if we have 2 is less than -1, we're going to multiply both of these sides of the operation by -3. So I'm going to have -3 times 2 is greater than -1 times -3. So -3 times 2 is going to give me -6. And -1 times -3, a negative times a negative is a positive, so that's 3. I know -6 is less than 3. So now let's look at our inequality symbols. Did they change? Yes, they did. So we know that it was reversed. Great. Now I have 1 is greater than -5. Let's divide both sides by -2. Now I have -1/2 here, and then I have -5 divided by -2, which is going to give me a positive value of 5/2. And I know that positive 5/2 is going to be greater than -1/2. And so I know that -1/2 now is less than 5/2. Now let's look to see if our symbols changed. They did, so they are reversed. Now we're going to examine the results and make a statement about what you notice and justify it with evidence. Well, here, when both numbers are being compared or multiplied or divided by a negative number, the symbol changes and the inequality symbol is reversed. All right, and this concludes our lesson for today.